Hi guys, in this video I'm going to give you a quick overview of the Singularity flight controller, and then I'm going to move on to doing some testing of the video transmitter module. We're going to really give it some abuse and see how it holds up. So to get started, you can see the board here on the right is oriented with the video transmitter module facing upwards and the SMA antenna connector pointing to the rear. There's a small arrow on the silk screen here showing the proper orientation of the board. This is how it should be installed. In each of the four corners of the board there are two sets of pins. These are the ESC connections for the motors corresponding to those positions on the quadcopter, so you can just wire them directly in without worrying about which ESC goes where. Over here we have the main LiPo power input marked with a plus and a minus, and just next to those are another two pins which are a power jumper for the video transmitter module. We're going to talk about that a bit more in a minute. Directly below here are the three pins for your RC receiver, as well as a three-way solder pad so that you can select to power your receiver with either 3.3 volts or 5 volts. Generally 3.3 volts is for a Spectrum satellite type receiver and 5 volts for most everything else. It's the same three pins for any serial RX type receiver or any PPM receiver. PWM receivers unfortunately aren't supported. The three pins at the top of the board here are for connecting your camera. You have a video input signal as well as a 5 volt power and ground output. I directly power my FPV cameras from these 5 volt pins and it works really well. You can, of course, if you wish, run a 12 volt step up regulator if you'd like to supply higher voltage for your camera. Moving down to the bottom right here are a set of 8 pins, including an output for your buzzer, telemetry output for your receiver, an LED strip output, and finally another 2 motor outputs. Obviously there are 6 motor outputs on the board and you can run a hex if you wish, there's nothing stopping you doing that, but this really is optimized for mini quad use. Moving over to the back of the board, we have a micro USB port, we have a JST-SH serial port connector, that's USART1, and we have TX and RX solder pads here, which is USART3. USART2 is actually the RC input pin, which is what allows us to do both PPM and serial RX on a single pin there. Going back to talking about powering the board, there are only 2 places you should ever apply a voltage to on the Singularity. One is the micro USB connector and the other is the direct LiPo voltage input pins. You can, of course, apply power to either or both of these points simultaneously without any problem. When you connect a USB cable to the Singularity, it will power obviously the board itself as well as your receiver via the power output for the receiver there. The only time your FPV camera and video transmitter will be powered is when power is applied through the LiPo pins. They will never be powered by the USB port. The video transmitter has some further safeguards in place and is only ever supplied power when these 2 power jumper pins here are bridged. Now you can either directly bridge those with a piece of solder or put some pins on there and use this small red jumper which is supplied with the Singularity. This ends up being really flexible overall, meaning that you can power the board via the USB connector on the bench and configure and not worry about anything overheating, or alternatively you can just pull off the jumper there and plug in a LiPo to your quadcopter and the video transmitter won't be on. You don't need to worry about heat or having an antenna connected. The next thing we're going to do is take a little look at what might happen if you do leave the video transmitter powered for an extended period of time with no airflow and without an antenna connected. What I'm going to do now is I'm going to power up the Singularity and use my RF Explorer to take some baseline measurements of the power output of the board. Following that, I'm going to then leave the Singularity powered for 1 hour with no airflow and no antenna connected at all. I'm going to attach the thermocouple from my multimeter to the heatsink on the Singularity, and we're going to have a look at the temperature of the board at rest and then after an hour. It's absolutely not recommended to do this, and it's not covered by warranty, but this is just a test and a demonstration of the hardware. I'm then going to take some further measurements with the RF Explorer, and we're going to have a look at how things might have changed and whether there's been any damage to the board. I've now connected everything up, and I've powered the Singularity board via the USB connector, and you can see that the thermocouple is reading about 26 degrees C. That's just in open air. Moving over to the laptop now, you can see I've got the CleanFlight configurator running, and the board is responding when I move it around. I'm currently running the latest version of Betaflight, and we are in 2 kHz, so our loop time is hovering around 500. Moving over to the RF Explorer software, we can see that the Singularity currently isn't transmitting anything at all. I have now hooked the board up to 12 volt source on the LiPo input pins, and I'm about to install the small red VTX power jumper. You can see that we are now transmitting on 5740, and the peak power output we're measuring there is around 24 dBm. Switching over now to the power channel measurement screen, we can see that we are hovering just around 400 milliwatts, which is as we'd expect. I now have the thermocouple taped to the front of the can on the RF module, which should be one of the hottest parts of the board, and I have the board powered by 12 volts from the LiPo input pins. I haven't currently got the VTX jumper installed, so it won't be transmitting, but I'll put that on now and we'll start the test. We've been running now for a little over half an hour, and the temperature is stabilised at around 74 degrees C. You would probably expect that if any damage to the VTX module was going to occur, it probably would have already happened by now, but we'll go ahead and do another half an hour and then take some more readings. It's worth mentioning at this point that although these temperatures seem high, all of the components on the board are actually rated for normal operation at these temperatures. The 2 lowest rated components are actually the data flash and the STM32 chip itself. Both of those are rated for normal operation up to 85 degrees C, so we're still well within that, and this is pretty much a worst case scenario. All of the other parts on the board are rated for between 100 and 125 degrees C, normal operation, so we're really not at any risk of damaging any of the parts on the flight controller right now. It may not be visible on the video, but I can quite clearly see the red LED on the underside of the board flashing away. So Betaflight is running and everything's still very happy, but we'll verify that at the end. Okay, we're about an hour in now, so I'm going to wake up the multimeter and let's see, we're still hovering around 74-75 degrees. What I'm going to do now is try and screw in the RF Explorer, which could hurt a little bit because the board's going to be very hot. Okay, and if you can, oh, that's interesting. We can see the temperature dropping immediately as the power now, which was being reflected back into the video module, is going off into the RF Explorer. Doing my best to get everything back in shot. You can see that I've now got the Singularity board connected to the RF Explorer once again, as well as to the laptop via the USB cable. I've got CleanFlight configurator up on the screen, so as you can see when I move the board, The 3D model is responding on the screen as you'd expect. If I flick to the RF Explorer software, hopefully you can see there that the power output is virtually unchanged at about 400 milliwatts. And if I flick back to the spectrum analyzer view, you can see the power output is again hovering around 23.5, 24 dBm.